Hi guys, today we're going to talk about another way to solve that is called completing the square. So you will need your completing the square note sheet, which is posted on Google Classroom with the said puzzle. You'll want a pen or a pencil and your calculator. We are going to solve quadratics by completing the square. So let's talk a little bit about what that means. We already know that the standard form of a quadratic equation is ax squared plus bx plus c equals 0, okay? But we also have talked about some different trinomials and factors and things like that. And so, for example, something like x plus 4 times x plus 4 can also be written as x plus 4 squared, right? Because it's the same thing as saying like 2 squared is 2 times 2. So this is the same thing, okay? And if we were to write that out as x squared, or if we were to multiply this out by foiling our box method, it would be x squared plus 8x plus 16. And we could set it equal to 0 for a quadratic equation in standard form. And this right here is considered a perfect square trinomial. Okay, so that's something we're going to be talking about. And if you look at this math term, it actually says that completing the square is the process of adding a constant to a quadratic expression to transform it into a perfect square trinomial. So that's basically what we're going to be doing. We're going to be kind of rearranging the left side of the equation so that it looks like a perfect square, because then what we'll be able to do is factor it into that perfect square trinomial so that it looks something like this. And then we can take the square root of both sides like we were doing in the last video. Okay, so it says here to find the number that completes the square, we are going to use the formula b divided by 2, squared. So b divided by 2 squared. I would write that down somewhere. That's super important. But in order to complete the square, we are going to take your b value, whatever it is, divide it by 2 and square it. Okay, so let's look at this first example. It is x squared plus 6x plus 8 equals 0. And it's already in standard form and set equal to 0. So the first step is to isolate the variable terms. So these are your variable terms because they both have an x on them. They have a variable, okay? So in order to isolate them, really what you're going to be doing is moving your c value over to the other side, okay? So that's what they did here. They subtracted over the 8. Then your next step, and I'm going to usually write this as like plus a blank plus a blank. So on each side, I'll add in a blank. And you're going to find what completes the square. So again, and remember, in order to find that, you do your b value divided by 2 squared. In this case, our b value is 6. So they did 6 divided by 2 squared. And 6 divided by 2 is 3. And 3 squared is 9. So that's why they chose to fill in these blanks with a 9. Then from there, they factored the left side, and because it's a perfect square trinomial, it factors nicely to be x plus 3 squared. And they simplified the right side, negative 8 plus 9 is 1. Okay. From there, they went ahead and took the square root of each side to get rid of that squared, and they were left with x plus 3 equals plus or minus 1. So that's when you split it up into 2 equations and you solve for x, just like we were doing in last night's video. So split it up into 2 equations, solve for x. Okay, so let's try one of our own. All right, so we have x squared plus 2x minus 15 equals 0. It's already in standard form and it's already set equal to 0. So we need to kick out this constant to the other side. So in order to do that, I'm going to add 15 to the other side. Okay, and while I do this, I'm going to go ahead and write this as x squared plus 2x. So my variable terms are on one side. And I'm going to write it as plus a blank and then equals a positive 15 plus a blank. Okay, because whatever we do to one side, we do to the other. So I put my plus a blank on both sides. Okay. Then to figure out what goes in that blank, I'm going to use my formula, b divided by 2 squared. And in this case, my b value is 2. So 2 divided by 2 squared. So 2 divided by 2 is 1. And 1 squared is just 1. So that's what I'm going to fill in those blanks. Okay. On this left side, we have a perfect square trinomial that we are going to factor. And on the right side, we are just going to simplify those terms. So 15 plus 1 is 16. So let's go ahead and factor x squared plus 2x plus 1. It's a perfect square trinomial with no lead coefficient. So we would put a 1 in the top and a 2 in the bottom. So what two numbers multiply to 1 that add to 2? 1 and 1. Because 1 times 1 is 1, 1 plus 1 is 2. So I could write that as x plus 1. And x plus 1, I can use my shortcut here. And then this can actually even simplify to x plus 1 squared, just like we talked about on the last screen. Okay. From here, it's nice because the x plus 1 squared is isolated, so we can now take the square root of each side, and that's going to cancel this and leave us with just an x plus 1 on the left side. And then the square root of 16, remember we need this plus or minus 4. So this is where we split up into two equations. X plus 1 equals positive 4, and x plus 1 equals negative 4. So then I would subtract the 1 over, and I get x equals 3 as one of my solutions. And I would subtract the 1 over, and I get x equals negative 5 as my other solution. And that's it. Okay, so we're kind of using what we used yesterday when we get to this point, but first we need to complete the square so that we get that perfect square trinomial and we can use the square root method. Okay, let's try another here. All right, so in this one, it is nice because they have already moved over the constant. So I'm just going to go ahead and rewrite this with my plus a blank on each side. So they've already moved over the constant. So now I'm going to write it, whoops. Equals 15 and plus a blank. So again, to figure out what goes in that blank, you take your b value divided by 2 and you square it. So in this case, my b value is just 6. So I would do 6 divided by 2. Square that. 6 divided by 2 is 3. 3 squared is 9. So that's what goes in these blanks. Okay. This side, we're going to go ahead and factor. So 9 goes in the top and 6 goes in the bottom. What two numbers multiply to 9 that add to 6? 3 and 3. So I'm going to write this as x plus 3, and x plus 3 are my factors. And then we're going to set that equal to 15 plus 9, which is 24. And then I'm going to rewrite this x plus 3 times x plus 3 as x plus 3 squared. And then now we can take the square root of each side. Whoops. So that's going to leave us with x plus 3 here. And then here we get into a problem where 24 is not a perfect square. So this is where we need to break down our radical like we were doing in class the other day. So I'm just going to pick two multiples of 24, which would be 8 and 3. Sure. Then I would break that down to be 4 and 2. Sure. And then I break that down to be 2 and 2. And then I can't go any further. So remember, when you get to this point, you want to circle a pair, and then whatever's left, you're going to multiply those. And that goes on the outside. So 2 times 3 is 6. And then, so that's still going to be root 6. And then 2 times 2, that's going to be your pair that goes on the outside. So 2 root 6. Okay. There's a couple other ways you could have done that. You could have broken it down to be 4 and 6 and then taken the square root of 4. You would have gotten 2 root 6. You could have broken it down to 12 and 2, then 2 and 6, then 2 and 3. So there's a couple of different ways, but either way, whatever you circle as your pairs, that goes on the outside, and whatever's left gets multiplied and goes on the inside of your radical. So we're just going to write that as 2 root 6. Okay. And of course, we need the plus or minus because we just took the square root of it. Okay. Then our last step is going to be just to subtract over this 3. And your final answer, which is going to look a little bit different than what we're used to, but it's going to be x equals a negative 3 plus or minus 2 root 6. Okay. And we don't need to break it up into 2 because we're not going to be able to simplify that 2 root 6 anyways, so you just leave it as is. As long as it has that plus or minus, we know that there technically are 2 solutions still, the positive and the negative. Okay? All right, then last example we're going to do today is x squared minus 2x minus 63. So again, here we want to start out by adding over that c value to isolate your variables. So that's going to look like x squared minus 2x. Then remember, we want to add our plus a blank. And then equals 63 and a plus a blank. Okay. In order to figure out what goes in those blanks, we are going to do b divided by 2 squared. Our b value is a negative 2. So negative 2 divided by 2 squared. Negative 2 divided by 2 is negative 1. Remember, negative 1 squared, be careful with this, is a positive 1. Use your parentheses. So again, I'm going to plug in a 1 and a 1. And let's change our color here. I need to factor this left side. So we're going to put 1 in the top and negative 2 in the bottom. What 2 numbers multiply to a positive 1 that add negative 2? A negative 1 and a negative 1. So I would write that as x minus 1 are my factors. And then set it equal to 63 plus 1, which is 64. I can rewrite this as x minus 1 squared equals 64. Then I can go ahead and take the square root of both sides. And I'll be left with x minus 1 equals plus or minus 8. Here's where you want to split it up to be x minus 1 equals positive 8. And x minus 1 equals negative 8. I would add the 1 over to solve for x in each of these. And I get x equals 9. And I would add the 1 over and get x equals negative 7. And those are my 2 solutions. Okay, so if it's nice where the radical breaks down, where it's a perfect square, then you're going to get your 2 solutions and write them separately. If it's like this one here where the radical, you have to break it down, and it's not a perfect square, then you're going to write it all as 1 with the plus or minus. Okay. So we will do some more practice with these tomorrow during Zoom. If you have any questions, let me know. Have a good one. Bye-bye.